important Linux commands. So basically, we're going to go over some of the commands we're going to be using during our series and when you work with Checkpoint. The information in that lesson might seem a bit dry, but the reason for that is I do expect you to know some of the information, from Linux world. And let's begin. PWD, it brings working directory where you are in a system. CD changes directory, CD/root, whatever, just changes, your directory. LS lists directory contents. MKDIR, it just creates a directory in U1, and RMDIR just removes it, the whole directory. All right, then touch creates a file. If the file exists, only touches the file or to update the timestamp. The file does not get modified aside from the timestamp. MD5 sum, it calculates the hash value for a file. It's useful to validate integrity of the file to see whether the file was corrupted during download or whatever. Chown, it changes the ownership of a file or a different user. Change group, same thing, but for ownership of the whole group. Then chmod, it just changes permission for the file. Alright, right now we're gonna go over networking commands. ethtool or ethtool, it's a really diverse command that is used for showing and actually modifying really advanced parameters of your network card and drivers, devices associated with that. It has a lot of syntax, so I'm just gonna throw it in here. Some of the stuff you can do with that is show information about your network card and its current settings. Who knows, maybe your networking administrator is going to ask you that question and you're going to be like, hey dude, I can give you that. It's going to be ethtool Ethernet XX, right? So you're going to have that information right in front of you. Show network statistics counters, including errors you have. Maybe you have some drops in the company, some network you get in latency and you don't know why. You going over the layer 2, 3, 4, maybe it's TCP, maybe IP, I don't know, right? But maybe it's happening on layer 1, on the physical layer. So with that command, you can check that, and I'm gonna actually show you how to do that. And stuff like, turning off auto negotiation, stuff like changing the amount of throughput the network card can work with, full duplex or half duplex, whatever, all that kind of information. And look at that. Blinks the LED on the network card. Might be useful, sometimes we go to the server room and it's not blinking, whatever. Maybe it died. If you type in that command and it's not blinking, maybe the interface actually died. It's a good troubleshooting set of commands here. Alright, so next what we're going to have here is netstat-i. It's a utility that allows you to view network connections, like routing tables, interface statistics, NAC connections, multicast memberships, whatever. A lot of information you can get here. You can check net interface statistics when you type in that syntax, netstat-i. You're going to get an overview of network counters. And it's going to be the same as ifconfig-s. So there is a lot of information here, right? It is really useful when you're trying to figure out where you have problems in your networking. When you try to understand at what level you get in drops and if you actually do get them. So normally only Rx and OK and TX OK should be increasing, like receive and transfer. It's basically normal packets that should come and go to the interface. If any other counters are increasing, we might have a problem. So look here, we have Rx OK, TX OK. OK means OK, right? Receive, transfer. So Rx OK indicates the number of packets received successfully. TX OK, the number of packets sent successfully through the wire. If it's increasing, It's absolutely fine. The packets live in the interface. Everyone's happy. All right. So the next thing, when you see arrows, Rx arrows or TX arrows. So basically what it means, if you get an Rx arrow or TX arrow, it indicates interface error occurred receiving the frame or packet. You can type in that command to get more specific information for that counter to identify the issue. The TX arrow value will increment among like crazy amount of reasons. It might happen due to any kind of collision on the link. It usually indicates a mismatch in duplex settings, MTU size, bad cabling, maybe someone stepped on a cable, whatever. You gotta check switch settings, check speed duplex. I actually had a case when I was working at TAC, at Checkpoint TAC. I actually had a case like that. I was able to figure out where the problem is just because I typed in that command. I saw that Rx arrow and TX arrow, they were increasing, and I knew something is wrong on layer 1. I didn't have to look for, IPs and TCP or firewall blocking it. It never got there because of that problem, because there was some kind of problem on the interface on that level. That command is really useful. All right, the next thing we have here, Rx drop or TX drop. It usually indicates that incoming packet was dropped by the interface for crazy amount of reasons. Maybe network buffer, was full, or IPv6 frame was received on the interface that was not initially configured for IPv6. The VLAN that wasn't, it didn't, it wasn't intended to be here. So it came here, it was dropped. Once again, use that tool to get more valuable information, either in a tool -s, capital ETH, and your interface. TX drop, stuff that you transferring and it's showing drop, it can be this similar reasons. Just use that command. Rx over, TX over, these are overruns. They represent FIFO errors, packet loss because kernel could not service the buffer in time. The buffer was filled up too fast, or the kernel couldn't empty the queue in time. That stuff is a bit more complicated, but if it's increasing, you know where to look. Terms like buffer in time, could not serve something in kernel, so it's not the interface. Something might be happening to your processor, to your cores, whatever. Just, now you know what it means. Another really useful command is called IP route. It's used to view and manipulate the routing table. If you type in the command IP route show, you're going to get the whole list of all routes available for subnets. So that command is really useful, IP route get. If you want to understand what is going to be the next hop, so the first address we type in, we type in IP route get 8888. So we know what is going to be the next hop and what interface checkpoint going to reach to get to the destination. Sometimes it's not really obvious, especially when it comes to a lot of networking problems. You don't really understand if it's leaving from the proper interface. So that command going to give you that information. IP forwarding, that mechanism is Linux command that turns Linux machine into a router. And since checkpoint based on Linux, Red Hat 5, we kind of need to understand that, because I had cases when that command was turned off by default and it caused a lot of problems. So you try to understand where the problem is, but your system is not a router. It's not able to route traffic. And simple as it is, all you have to do is just to enable that parameter, that value in kernel. Just enable or disable. Out of the box, when you get your appliance or install an operating system, usually it's going to be enabled. But for some crazy reason, I've seen it when it was disabled. Maybe people, administrators did something to his system, it just turned it off, and then they weren't able to understand what's happening. Just keep it in mind. Pretty easy to do. All right, so in the next lab, it's not going to be a lab, it's just going to be the second part of commands, but we're going to move to the CLI. I'm going to type it in there. We're going to check CPView and why we need that, how we can use it. Top command, df-h, fw unload local, show configuration, cpconfig, and we're going to change shell as well. That command, I want to, make a clear explanation why we need it, and see you in the next lesson.